Okay, so let's start. Leave this one here. Okay. All right, guys, so let's start. Theory of Structure, CE 312. That's the class we are here online. First lecture today. So welcome, everybody. Today we're going to go over the dynamics of the class, also over the syllabus and what we're going to do in this class. Then I will introduce the structure analysis or the structure engineering, this concentration that we're going to touch a little bit more deeper on this class. Okay, hopefully I'll be able to talk a little bit more about loads, structure systems, and a few things today as well. I'll also show you some of the bright space stuff that we're going to use this online class. So very important, a few minutes before we start the lecture. Okay, most of you know me already. I'll introduce myself, but before that, I like to pray before the class. So I invite you to pray with me. If you don't want to pray, it's totally fine. Just be in silence, and we start every single class like this. Okay? In the name of the Father, Son, Holy Spirit, Amen. Direct the Lord, we beseech you, our actions by holy inspirations, and carry them on by grace's assistance, that every prayer and work of ours may begin always from you, and through you come to completion, through Christ our Lord. Amen. All right, guys. So even though for those who are here live with me, most of them know me, I'll introduce myself once again for those who don't know me and are watching it, the recorded lecture. So my name is Bruno Guidio, Dr. Bruno Guidio, Dr. Guidio. Anyway, so I'm assistant professor of Pretex here in the Civil Environmental Engineering Department at the Engineering School. My office, even though you're not currently in Pangborn, but anyway, next semester, if you're around, you can stop in my office, Pangborn G18, the ground level. I'll be there most of the days. If I'm not in the office, I'll be in the classes, so in the classroom. So you can just stop by, say hello. All the communications for this class and mostly communication with me is by email. So guidio@cua.edu. I like to say that because I actually have two emails. Okay, guidio@cua.edu and 20 piruki@cua.edu. They are same, both emails are mine. Okay, so they go to the same inbox. Just one is kind of a fake one, the other one is the true one. This is because I got my PhD at CEE, meaning I was a student at CEE years ago. I finished my PhD 2020, but my first year, well, here at CEE was when I was exchange student in 2015. Then I went back to my country, which is Brazil. I'm from Brazil. And then later on, I came back to CEE to finish my PhD. So by that time, in 2015, the 20 Piruki Guidio was the email that they gave me. So very huge and long with numbers and my middle name, all of that. And then I came back to CEE in 2024 as a professor, as a faculty here. So I'm finishing my second year this summer, actually. I don't know how to count it. So this is my end of my second year. And then when I came back, I asked the university for another mail. They couldn't give me because of my ID, blah, blah, blah. And they gave me the guidio@cua.edu, another email that I can use, but they go to the same inbox. So whenever time that I mail you, probably I'm going to mail you from my guidio@cua.edu. However, my Brightspace is linked with the 20 Piruki Guidio. So If you receive any of those emails from any email from any of those emails, it's me. Okay, don't worry. And then you can mail anyone. Okay, you mail me from to anyone actually. Okay, I like to say that because when you go and type my last name in the Gmail, you're gonna show both, so people always get confused. But feel free to email me using any one of them. Okay, so as I said, as a student here at CEE, I was TA for many classes, including this class here, Theory of Structure. And actually structures is my concentration. Okay, for you in civil engineering, you have to pick one concentration. The structural engineering is my concentration. Okay, if you are dual degree, joint degree, you don't need to pick up concentration, but if you are just a civil, you need to pick one concentration. Okay, and I like to say that this class is kind of an introduction to structural engineering. Okay, so you're gonna have the taste of structural engineering stuff right here, even though we're gonna use more hand calculation than softwares. um, at least you're gonna have some sense of it. uh, and then um, that's that's me. Okay, I like to say, most of you know, outside the school, outside the college, I do have a family. So these are updated picture from my family. Most of you know that I was in the parental leave in this spring semester because the baby right there that you can see, baby Leo, he was born in December. Then I got my parental leave for this semester, the spring semester. So I'm coming back teaching online actually now, after what was it, 5 months? 5 months without teaching. So I may be a little bit still rust. I need to pick it up once again, the pace and everything. So please be patient, okay? But I do have a family, so especially here at home. Okay, you may hear the kids playing over there. Um, After class, I'll be with the kids. I have to go to the playground. I have to play with the kids. All of that stuff. Okay, so um, I'll do my best to accommodate everybody, even though you are watching it in the recorded stuff. You can mail me, we can meet, we can talk, and I will answer you as soon as possible. But just keep in mind, I have a family, you have a family, maybe have internship, maybe you want to go hiking, biking, swimming this summer. Okay, so everybody's going to be busy this summer, but we are here in class, learning and teaching. Okay, so anything that you need, let me know. Um, what else? Of course, we're not in the school. My office hours is not like one thing here in the office, but I'm able to talk to you. I'm available to talk to you regarding anything. Okay, if you have any questions, if you're struggling with the class or the online stuff, if you need any help, please let me know. Okay, if you're struggling in your internship, if you are struggling deciding classes for fall, if you're afraid of anything, please let me know. Okay, of course, in this online environment, the best way, email me. Okay. If I can answer you by email, I will do so as soon as possible. Okay. If an online meeting is needed, okay, email me some time options that works for you, and then we can meet, we can chat via Zoom, no problem. Okay. Um, I just want to let you know that I'm teaching another class as well this summer, which is aesthetics. All of you already took aesthetics. I'm teaching during the morning from 10:45 to 12:50, something like that. Okay. So I'm not able to meet during that time. So probably before this class, I have like 15, 20 minutes before this class to meet you, or really early in the morning from 8 to 10 o'clock, something like that. I can meet you Tuesday, Wednesday, and Thursday. Okay. Or we can meet after this class. Okay. After this class, I can stay a little bit more and meet with you. Okay. Just let me know in advance. Um, However, yeah, sorry. Plus, I can meet you Mondays and Fridays, yes. Monday and Fridays I don't have class, so I can meet you anytime. Just email me and then we can chat. Sounds good? So that's how we're gonna kind of handle the office hours. Okay. Any questions so far? Please let me know in the chat or open your mic and speak because I cannot see you today. Okay. Okay, I'll keep going here. For the, let me see if I can remove this Zoom stuff. Okay, for the online class. Okay, the class will meet every Tuesday, Wednesday, Thursday, 2:30 to 4:35. I do expect sometimes when it is needed to have kind of a break after 1 hour, just for us to drink some water, walk a little bit, or you get something to eat. I don't know. Okay, because I understand that 2 hours is kind of a lot of a lot of hours to pay attention. So I'll do my best, okay, to accommodate it. And would be great if you can attend every or almost every class via Zoom online here with us. However, I do understand that most of the students for this class they are having uh, the internship. They are working right now in the middle of the day. So I am recording the class and I'm posting the recording as soon as possible. Okay. After the class, I close Zoom, and Zoom we will upload this to the cloud, and then I will send the link to you guys. Probably I'll make a kind of a list of classes in Brightspace so you can check it out. And I'm also thinking about to post on YouTube so you guys can have like a playlist. Once you finish, you start another one. I think it's gonna be much better. I just need to stop, create that playlist, upload. I'll think more about it today after this class that I have to handle the recording. Okay. Uh, uh, However, guys, if you're not able to attend online via Zoom right here, right now, okay, it is your responsibility to watch the content, review the problems, reach out if you have any questions. This is very, very important. Okay, I'm not gonna pick. I'm not gonna ask you if you are watching the content. I'm not gonna email you and just demand you watch the content. No, I'm gonna mail you the link. You watch if you want. Okay, but it's your responsibility, okay, to watch it, to review the problems, to review the homework, to study the homework, to study the lectures here they are going to be recorded. Okay. So I don't have any problems if you have to take this class 100% online, 100% in YouTube playlist, Zoom Cloud. I have no problems. However, okay, I do expect you to learn from this class. I do expect you to get the knowledge from this class. So I really want you to watch it. I don't care if you're gonna watch the YouTube in 2x, 2.5x. Okay, Bruno is speaking too slow, solving the problem is too slow. I'm gonna just put 2.5. It doesn't matter. I don't care. Okay, you don't need to tell me that. I really want you to understand the stuff. If you understand the stuff, great. Okay, and this is going to be a high-paced class. It's going to be very fast because most of the time I'm not in class waiting for you to solve the problems. If not, the recording is going to be 5 minutes in silent. Okay, I'll try to just go fast and fast for the online class. Sounds good. So it's your responsibility to do all of that. Even if you are watching it record online, actually you can watch the record later, of course. Just watch the record stuff, maybe how Bruno solved the problem. You go back there in that specific time and then watch it again. Okay, feel free to do so. All right, homeworks I do are due every Monday night. Okay, unless I state otherwise. As you saw in Brightspace, and hopefully you already saw it, I already post homework number 1. Okay, homework number 1 is already there. Why I'm doing that? Because my goal is I give you a lecture and then you can solve a part of the homework. Then Wednesday, another lecture, and then you can solve another part. Thursday, another lecture, and then you can solve the whole homework. Okay? Then by Thursday, you're going to be able to solve the whole homework. Okay? However, I understand that people are going to watch these lectures during the weekend because they are working, they're busy, so they're going to watch all the 3 lectures during the weekend. So you can solve it on during the weekend on Monday. Monday you can ask me questions, I can help you, and then you have to submit it by the Monday night. And then Monday night I'll post homework for second week, and then we keep going. Okay. Remember, you should be able to use your homework as a study tool. Okay. So make it clear, clean. Okay. Explain your steps. Okay. Do like a good handwriting. Okay. And big enough for me to be able to read it. Okay. And how are you going to submit? Well, most of you already took my class. You're going to scan your submit. You're going to scan your solution. You're going to create a PDF. Guys, I really need a PDF. Okay. You can scan using your, if you have iPhone, go to your Notes app. You can scan using that app. There are a bunch of apps that scan and create PDFs. Okay. I don't want a picture. Okay. I don't want you to taking picture, PNG, JPG, and upload in Brightspace. I want a PDF. So I'm going to be able to annotate, print, and just save me some time. Okay. Please see if like the orientation is the vertical orientation. Okay. All of that. Make sure I can read the PDF. Okay. High quality or good quality of PDF. If the light is good, all of that is important. Okay. So I really want you to guys to pay attention to the homeworks. Okay. Um, and do your best on homeworks. Now for exams, we're gonna have 2 exams, midterm and final exam. Unfortunately, this online class, I don't have so much, like 6 weeks. I don't have, if I cut so much with tests, we're gonna just lose a lot of days. So I'm gonna go for midterm and final exam. How this is gonna go? My tentative is using the quizzes on Brightspace. There is a function in Brightspace called quizzes, and the quiz is gonna show one question. Sorry, you're gonna be able to answer that question, then you're gonna go for another question and keep going. And how are you gonna solve the test? You're gonna get a paper, okay? You're gonna see the question, you're gonna solve the question in the paper, you're gonna scan, upload, and go to the other question. Okay? Solve, scan, upload. Solve, scan, upload. Solve, scan, upload. Okay? So your answer is not gonna type because it's just numbers and equations. You're gonna solve by hand, scan, and upload. And then you go to the other question. Okay? So that's why I really need you to pay attention how or learn how to scan, create a PDF, and upload in Brightspace. Okay? Because you're gonna do this for the test. You're gonna do this for the midterm. Okay? And also because the exam is gonna be a time limit on that exam. I'm gonna give you a few hours. Of course, I'm not gonna give you just 1 hour, 2 hours, probably 3, 4, 5 hours to finish the exam. Okay? So be ready to work on the exam for a few hours. Okay? You're not gonna be able to stop the time, go have lunch, and come back. Okay? You're gonna just, once we start, your time is gonna run, and then you have time to finish the exam. Okay? For those who are working, watch online. Would be great, wonderful if you could get the day off, the morning off, the afternoon off, okay, doesn't matter. Talk to your boss right now, okay? Tomorrow, talk to your boss. Say, boss, I have midterm and final exam on Wednesday, June 10th. Final exam is Thursday, June 25th. I need the day off. I need the morning off. I need the afternoon off. Anything that you can give to me, I'll take it. Okay, talk to your boss. Okay, talk to your family that, hey, those days I'm gonna have tests. Please be in silence. Okay, I'll be in my room for a few hours. Do not knock the door. Okay, all of that is important. So plan yourself ahead. Okay, and just plan it. Um, if you cannot get the day off, you're gonna have to start, I don't know, 7 p.m., 8 p.m., and you have to finish by midnight. Okay, you have just that day to finish the test. I'm not gonna allow you to do the test any other day unless something really huge happen and you tell me. Okay, if not, I will expect you to finish until midnight, start 8 p.m., go until midnight, and submit your test. All right. So plan yourself. Sounds good. We're gonna get in more details once we get close to the midterm, and then you're gonna understand. Maybe I can, yeah, probably I'll do some kind of a test with you guys, make a fake quiz so you guys can see what I'm meaning by it. Any questions about homeworks and exams, please tell me right now, those who are here and can
I had
speak.
one question.
Yes, go ahead.
For homeworks, if we are able to do like a digital but written PDF like on an iPad, is that all right?
Great, great, good question. It's all fine. Homework's all fine. I use the iPad. Most of you know I use the iPad. I'm gonna be using iPad. The solution I make on iPad as well. So for the homework, if you have iPad digitally, you can solve it. Just get the PDF, solve it digitally. It's okay. Okay, no problem at all. But uh, for the exam, the best would be by paper, or even the iPad, like using, not gonna be able to have the statement, but you can use the iPad to solve it, to write it down. It's okay if it's easier for you. I have no problem. Okay. Any other question? Okay, so let's keep going. Next, about specifically about this class. Okay, same as statics. Those who took with me, these are high demanding class. Okay, a lot of different topics in this class. Um, at least in the beginning, it's going to be kind of a topic per day, but then we're going to go in some topics that are a bunch of things inside this topic. We're going to be able to do same stuff, but in different structures. So, but even though it's just different approach, so you have to put some effort on it, okay? And it's going to be plus this online class, high pace class, so it's going to be really fast, really fast. So you have to pay attention, you have to review it later, you have to do everything possible, okay? And same as statics, guys, you need at least C minus, aka 70% to pass, okay, this class. And I believe in this class, I just have CA students. Um, so that's for all of us, okay? You need C minus for this class as well, same as you needed for statics, okay? Same as you needed for mechanic of solids. You need C minus in this class to pass, okay? Last fall, around 12% of the class failed, okay? And almost 20% got a C minus. So they were almost there, okay? So please, please give the best as you can, okay? And this is a fall semester with time to solve, time to ask questions, to digest the content. It's online class, okay? And again, even though I'm trying to be a good professor, try to understand. Um, Most of you know that I'm not so easy with the grades if you don't show effort. Okay, if you don't show me that you are giving everything that you have, okay, you don't need to email me in the last week asking for a grade. Okay, not gonna happen. Okay, so I want to see some effort. I want to see people fighting for the grade, giving everything they have to understand the problems. Okay, show me you are interested, you want to understand, and that's it. All right. Also, I always receive this feedback. Whenever I finish, I got um, the feedback from the CUA that you guys figured out for statics for the other classes. And people always complain or say that, hey, Bruno, the homework was harder than the classroom problems. Sorry, guys, but that's what it is. Okay. In the class, I give you uh, the tools to learn and for you to think, understand the concepts. But in the homework, I want you to put the concepts in test and also bring your engineering knowledge, engineering thinking, critical thinking to solve a little bit more difficult problems. What is the point if I give you just easy problems at the homework? Okay, you have to put some effort. Okay, that it is what it is. Okay, so spend time solving problems, spend time solving homeworks, extra problems. Okay, those classes, you have YouTube videos, you're going to be already in the YouTube watching my class, you're going to be already here in computer. Okay, Google YouTube videos on the topics, questions, online search. Okay, we have a bunch. Okay, hey guys, AI is here. Okay, get my problem, put in AI, ask AI to create different problems with the same configuration, the same topic. AI is going to give you one, two, three, five different questions, try to solve it. Okay, um anyway, I want you to be in front of your knowledge, in front of your intelligence, of like desert of search for more. Okay, do not be just content happy with what I say here. Okay, just go forward a little bit. Okay, do your best in the homeworks. If you have questions, ask me. But then find another problem here and there. Okay, see if you are completely, if you completely understood the problem, and that's it. Okay, so spend time solving the problems, spend time solving homeworks. All good. um Let me see. Okay, yeah, so the book that I'm going to use is Structure Analysis by Hibbeler. So um this is the 11th edition I'm gonna use. You can also use the 10th edition or any edition actually, just for you to read more about topics, read more, find more problems. I'm gonna take some problems from the book. I'm gonna take some problems from other books. I'm gonna create some problems. But even though if you find a book online, you can find other problems. Okay, I think there are some books, different books online, so you are free to use them as well. Okay, but this is the book I'm going to use. Also, I, I believe you're not gonna have time on doing this activity, maybe one chapter or other chapter. But from last fall, I've been using this book, Why Buildings Stand Up. And then last fall, the students read the book with me because it's a really good book for you to understand more about structures. However, here we just have 6 weeks. I'm not expecting you to read the book in 6 weeks. Even though if you like reading, I do recommend you to get this book, Why Buildings Stand Up. You're gonna be really good, especially if you like structural engineering. If you want to understand a little bit more structural engineering, and plus if you are a dual degree, this is the right book because Mario Salvadori, who is the author, he is an engineering slash architecture. So his language, his writing style is for both. Okay, so you're gonna enjoy this book. That is, this book you can find online. The PDF students found it, but also in the Amazon. I think it's $9, $10, something like that. So you can get a book. I may assign you a homework to read one of the chapters, but if I do so, I'll send you the chapter, the PDF, if I found it, and we can discuss it later. But for those who like to read, I do recommend reading this book. All right. And again, this is just a storytelling book. There is no equations, no, of course, equations to show you something, but no problem solved. This is just a storytelling book. Okay, very good. Okay, with that, let me go to the syllabus just uh, to show you a few things more before we start the lecture. Okay, bright space. I think everybody knows how it work. Right here, content, already post. Not homework, week one. Okay, lecture one, that's what I spend time. And then have lecture one right now. That's what I'm about to start. Already post lecture two is gonna be the trusses for tomorrow, probably if you have time. Lecture three is gonna be probably SEP 2000, so it's gonna be software. I don't have anything prepared, just going to the software, and maybe I'm gonna create a problem and post it later on. But here's gonna be the homeworks and the exam. If you need it, the Zoom link is always here for you, and syllabus is gonna be here. If I need to update anything, is gonna be there. Before going to the syllabus, assignments, okay, I already post the assignment one right here. I believe is you can visualize it, assignment one. Um, Grades, you can see your grades, and this is going to be where the exams are going to be quizzes. Okay, quiz list. So probably I'm going to make a fake quiz here so you know what I'm saying about quizzes. Okay, what else? Discussions. Feel free to post here anything that you like to discuss or anything interesting for us to see. Grades, and that's it. Okay, pretty much. Let me go to content and go to the syllabus. Okay. It was like this. Okay, theory of structures. What I'm gonna do in this, what I'm gonna learn in this class. Well, we're gonna learn principles, methods to analyze structures. Okay, in other institutions, this class is called structure analysis. So we're gonna analyze structures. We did something similar or very similar in statics, where we analyze some trusses, beams, shear moment diagrams. We're gonna do this here as well. So you're gonna feel that sometimes it's kind of the same, but it is not. Okay, it is not. We're gonna have something more. Okay, but we're gonna analyze beams, trusses, but also we're gonna analyze frames. That one thing that we didn't analyze in statics. We're gonna discuss about loads, um, methods to calculate deflection. I believe you guys did something here in deflections for mechanic of solids. If I'm not wrong, you guys did the double integration method. Maybe if someone can confirm to me, I think that's what you guys did.
Yep.
We're not gonna, yeah, okay, thank you. We're not gonna use double integration method for many reasons. Okay, we have many methods to calculate deflections. Here we're gonna use a more straightforward method. So I'm not gonna work with integration, so you can breathe, you can just relax. Okay, but also we're going to use SEP 2000. So as I said, I do expect you to be able at least to access SEP 2000. I'm not sure if you're gonna be able to save the file, but it's okay. I just want you to get used to it. Maybe you are in the ASC teams for steel design, concrete design, the concrete canoe team. Maybe you're gonna use it later on. maybe you're gonna go to your internship, they're gonna use SAP 2000 or any of the softwares. So I want to introduce it to you so you know the stuff, what is happening and what you can visualize on those softwares. So I'm gonna in a moment tell you how to access SAP 2000. At the end, we're gonna also talk about influence lines, which is what happened if you're analyzing a structure that the load is moving, aka bridges. Okay, let's say we have moving traffic moving, how we analyze those bridges. So we're gonna see here. And then later on, the last topic is gonna be static indeterminate structures. Are those structures that we cannot solely straightforward using just statics. Okay, they are indeterminate. We have many more unknowns than equations. So how we deal with those structures. So that's what we're gonna do. Okay. Online, blah blah blah. I already talked about it. Um, Objective outcomes. You can read it later. What else? Books, structure analysis, as I said. Calculator. By now, everybody has a calculator. Okay. Uh, you're gonna use it a lot. Okay, SAP 2000. How are we gonna access it? First of all, I need you, if you are, if you, the syllabus is open right now, please go click here. Leave this one here open if possible. And actually, you can already go here. First of all, remote access request form. You're gonna click here, okay? You're gonna see this email. You just record, submit. That's it, okay? And then the text service, they're gonna allow you to access SAP 2000, okay? So if you can't do it right now, if you're in the computer, you can do it. Please do it right now. Later on, okay, what are you gonna do? You're gonna follow these steps, okay? You have to go to vpn.coa.edu, okay? You're gonna come here, probably student, login. Let me see. Get your ID here. I don't know. Oh, because I'm not student. So your do account does not, yeah, because I'm not student. But you have to come here and try to download this VPN. Okay, why I'm not be able, I'm not sure. Let me try again with the work. I already did it. Let me see. Oh yeah, because I'm a professor, so that's why. So I'm gonna go to my phone here. I approved, and then you're gonna see this one here. Download for Mac. In my case, I'm using Mac, but you're gonna see whatever you have. So this is your VPN to access it. Then you're gonna open the VPN. The VPN is right here for me. As you see here, I'm gonna give you how to do that. vpn.coa.edu. You're gonna connect. I'm not gonna connect if not. I'm gonna lose connection here. And then once you connect to it, okay. Let me see here the steps. All of these, blah blah blah. Right here, you're gonna go for apps.coa.edu. Okay. Uh, I need a VPN to access this website, so I'm not gonna be able to show you right now. But once you go, you're gonna see this screen, and then you're gonna be able to download SAP 2000 as a file like this, and then we're gonna be able to open it. Okay. So what you need to do is fill out the request form, install the VPN. That's it. Okay, that's it. That's what I need from you by Thursday. Okay, by Thursday. Hopefully they will approve your SAP 2000. Okay, that's what you need to do. If you have any questions, let me know. Okay, but the link is here. You can just follow it. Very straightforward. Sounds good? Any questions? All good? Okay. Okay, keep going. Attendance, as I said, You're responsible to watch the recorded class, assignments. You already know the stuff, homeworks, clean, clear, units, um, box your final answer if possible. Exams is going to be online. Okay, late assignment. If you really need to send me later, let me know in advance. Okay. Okay, AI, guys. I already told about told about AI. Okay, use AI in your favor. I'm not against it. Okay, use it. Use it to to create new problems. Okay, but pay attention. Whatever. Oh, let's see if AI can solve the homework. Yeah, probably AI can do a decent job, but you have to know the stuff in order to find if the AI is doing a good job or not. Okay, that's the thing. Engineers are using AI, but we still need engineers to review plans, to review drawings, to review assumptions. Okay, we still need your critical thinking. So you need to be able to read it and see if there are errors or not. Okay, so please, 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 if you're using AI, make sure you review it, understand it, and all of that stuff. Okay, and sometimes you're gonna ask AI, create a problem for me for this topic, and maybe AI is gonna get something wrong in the statement, and you're gonna be able to judge it. Okay, that's what I want to see. Okay, you just kind of seeing if it is all good with AI. Okay, I didn't do it this time. Probably I'm gonna do for the next fall, but last fall I took a statics problem and put it in different AIs, and I got three different answers. None of them 100% correct. Of course, this was 1 year ago. AI is much better right now, and every single day is much better. So just pay attention, okay? Pay attention. I really want you to be able to get your knowledge and just see if it is AI is doing a good job or not. Okay, so that's the thing that I'm gonna talk about AI. Okay, I am not against it. I use it every single day, probably. Uh, so feel free to use to your benefit, okay, to your benefit. But I really want you to get the knowledge. Okay, that's what I'm gonna say about AI. Grades, homework 30%, midterm 30%, final exam 40%. So as I said, I didn't have so much space and time to have another exams. So give your best on the exams, okay? Give your best in the exams to get good grades. In the grades case right here, we need C minus 70% at least. Last thing here before I jump to the lecture. Syllabus. We have a tentative schedule here. It's already 3:30. I'm not gonna be able to finish all the lecture today. Maybe let's see. If not, I just keep it going tomorrow, and then talk about trusses. If we need, we talk about trusses again on Thursday. I'm gonna kind of do something like that. I'll try my best to review concepts uh, every Thursday, the concepts that we learn in that week, so we are on the same page. So we're gonna do trusses next week. We're gonna shear moment diagrams. We're gonna review from statics and mechanical solids, but we're gonna have more different things, triangular loads, hints, and then we're gonna talk about frames. Okay, that's the new thing here, frame superposition. And then we're gonna go for deflections. Okay, use energy method, the unit loads, beams and frames. We're gonna review, and this Thursday we're gonna review for the midterm as well. Tuesday, June 9th, I'm gonna go a little bit for SEP 2000 once again, but using more like a study day as well. I'm gonna bring example uh, in SEP 2000, but I'm gonna also be taking questions for the midterm, which is going to be June 10th. Okay, and then June 11th, I'm canceling the class. Um, Mostly because I'm gonna be in a conference. Okay, Actually, I'm gonna be in the conference in June 10th as well. So it's gonna be our midterm. So it's gonna be all good. I'm gonna be able to answer questions, all of that. But my presentation is June 11th. So I'm gonna be in this conference. So I'm canceling the class. And then June 16th, influence lines, and then keep going. One more week. And then we do Tuesday a final exam review. We do a study day Wednesday, and final exam the last day of classes. Okay? If I need to move stuff around, I will let you know, but that's pretty much what I'm planning to do. All right. Any questions regarding syllables, the dynamics of the class, the recordings, anything like that before I go to the the topics for today? Lecture number one. Anyone? All good? All good? All good? Okay. Um, okay, so let me share my screen once again. And this time I will use my iPad. I didn't mention, but I think most of you know already. Okay. For example, lecture number one is already here like a presentation, but I'm going to use my iPad, make some notations. Okay. But lecture two, that's pretty much what I'm going to do most of the time. Okay. We have the lecture, we have a space to solve problems. I'm going to use iPad. And then after class, I'm going to post the completed PDF for you as well. Okay. So for those who never took my class. All right, so let me share my screen, iPad screen. All right. So right now is the time that I cannot see the chat. I cannot see the you guys. So if you have any questions, please stop me anytime and ask the questions if it's not clear. Okay. I will I will buy today a second screen, a small screen to give to put here for me starting tomorrow or Thursday. All right, so let me see if it is working. All good. Okay. All right. Theory of structures. Okay. Where is the beginning of structure concentration here at CEE? We're going to study more about structures. So, what do we do in theory of structure? As I said, many institutions name this class as a structure analysis because it's where we begin. Okay, understanding how structure resists loads is the key to building a safer tomorrow. We're going to analyze structures, the behavior. Okay, and this is the first step to design actually. Okay, what do we do when we design? What do we do first when we start designing? Well, kind of we just guess. Okay, not like that, but kind of guessed. We have like a some idea of my design. I have some idea which cross section I'm gonna use in this beam. I have some idea if I'm gonna use steel or concrete. I have some idea how many rebars I'm gonna put in this concrete. I have some idea how big is gonna be the cross steel beam in this as the design. But then what I need to do, I need to analyze and see if it is gonna work. If it doesn't work, I'm gonna design another one. I'm gonna pick another one, and what I'm gonna do, I'm gonna analyze once again. So this is structure analysis. Okay, we're gonna consider everything that we have: force, loads, stability, the materials that we have, and I'm gonna analyze the structure, analyze how in which we using which ways, which means, well, we're gonna analyze depending on what we are looking for, analyzing for tension, compression, bending. We analyze for a friction. We're analyzing a cable. We analyze a beam, a column. Okay, we analyze the concrete. What is the material that I'm gonna consider it? Okay, so this is the class, structure analysis. And what are my limits? Maybe the limits are the strength of my concrete. Maybe the limits are the strength of my steel section. Maybe the limits are the deflections. Okay, sometimes the strength is enough. However, the deflection is not enough. I'm here in the hospital, which the deflection should be really, really small. But my design is good. I can resist those loads. However, my deflection is big. I cannot have that cross section. So I do another analysis. I pick another design. So those are the things I'm going to start discussing and kind of keep in mind for the structures. Okay, so that's what we're gonna do in this class. So why are we here? Theory of structure, structure analysis. Okay, we need structure analysis in order to design. Okay, in short, structure designing is the sizing and arrangement of structures. Okay, and the components to safely support the loads. Okay, this is design. We're gonna size and arrange the the components of the building. What are those components? Well, we have slab, okay, slab right here, columns, we have beams, we have foundations, okay. It's pretty much what we have, and we have how we size these, how we arrange those structures. Well, we need to find the loads, the main loads in those structures. Here's the nursing building right here. Okay, they had to consider all this load of this facade, all this the classroom inside, the roof as well. We have what open roof here. People is gonna stand. So all of that we have to consider. Plus all of those materials, maybe have like some machines here they put on the top to finish the building. All of those we have to consider as loads in order to design those columns, in order to design those columns here, those arcs as well. Okay, those beams here. Okay, those this is kind of what structure engineers do. Okay, that's what we do. Okay. Um, so the theory of structure analysis is the determination of the effects of physical structures and system when subject to loads. Okay, so when we apply loads to structures, what are going to be the effects? Okay, and what I mean by those effects, support reactions. Well, you guys know, you already did it a bunch of times. We have loads, blah blah blah, and we have action, reaction. 30 law of Newton. Okay. Sometimes I want to know the internal force, the resultant axial force, shear the moments. Okay. You took mechanics of solids. Sometimes you want to know the what do you start the mechanics of solids? I believe you start with torsion. Okay. You did some axial force because you want to know what stress, force divided by area. So you want to know the axial force in order to find the stress. Okay. What else? When you apply loads, well, deformations. Okay. As you said, you saw some uh, double integration method to find what deflection on beams. What else? Rotations. Okay, we're gonna apply force. It's not gonna only deflect. It's gonna kind of rotate as well. Okay, those are effects. And what type of loads we have to cause those effects? Well, we have some examples here. Okay, we have some what we call gravity loads. Okay, that's pretty much what we call, sorry, dead loads and live loads. What are dead loads? Dead loads are the self weight of the structure. Okay, right here, all these stones, concrete, the steel, this glass, the window glass, um, the roof, all of that, that loads. Okay. And what are the live loads? Well, live loads, people. Okay. What else? Chairs. Okay. Tables, computers, live loads, things that can move. Okay. Things that can move. We design or we analyze the structure, okay, by considering some dead load and live load. How many people are going to be here, okay, in a square? But also we have environmental loads, which is wind, rain, snow, ice, seismic. We don't have seismic that much, or people say a few years ago we had seismic here in DC, but we have wind, rain, snow. Okay. So in order to design this column here, we need to determine how much snow is going to be here. How about the rain load? Okay. And we have snow, but sometimes just have some ice there. Ice is going to stay there for a few weeks. Okay. And all of those loads are going to cause reactions, internal force, deflections. Okay. So see how the structures behave. That's what I want you to see in this class, how they are behaving. Okay, let's take a look here. uh, Structure loads, as I said, we have all of those. Okay, various loads imposed on the structure. So the first thing that we need to understand, load is very important, very important. You can get a post-it and say study about load path. Load path, this is huge. Load path, we need to visualize how loads are transmitted between among the structure. It helps engineers sometimes eliminate unnecessary members, strengthen others, or identify potential problems. So once we understand how the load walk goes in our structure, we start understand how we design the structures. We start understanding, hey, this column here is really necessary. Can I remove this column and distribute this load to other elements, and how this is going to be? Okay. Some Maybe someday your job is going to be the following: the client is calling you, say, hey, i I bought this house here, but there is this column in the garage, but I really want to remove this column here because I want to fit another car of mine. Am I losing this space because there is a column right there? And what do? First thing, you need to understand the load path. What's going on in that house, in that garage? Okay. If I remove that column, where the load goes, and then I start what? Analyze the structure. This is gonna be strong enough to hold it. Then we start thinking about. Okay, what I have to do to reinforce the structure in order to remove that load, that column. Okay, so we need to understand. And basic, what is the basic that right now I want you to visualize how loads work. Okay, first we have this lab, right? We have this lab, people are here, we are in the classroom. Okay, we're having party. Okay, this is lab, we are jumping. We have the books, we have computer. This is a computer lab. Who is gonna get that load first? Is gonna be this lab. See here, see this lab, guys. Okay, for loading. Okay, we are here. We are putting here my house. It is a wood timber house. Okay, timber framed. Right here, I'm jumping here. Okay, I have loads. The main table here is applying loads where in the floor And what is the floor for concrete? For is it slab? Okay, I'm putting load on this slab. So first one to receive here, most of the time, is slab. And what is the slab is gonna do? He's gonna distribute the force right here. He's gonna distribute the force to who? Okay, who is gonna get this force? Take a look here. The floor beam or joist, depending how, if you are working concrete and steel, in wood, they have different names, but let's say call just beams, okay? By right now, the beam is gonna receive this load. Bruno, I have a lot of beams. How I know how much load is gonna go to that beam? Wait a minute. You're gonna get there. We understand the load path first, okay? Slab, go to the beam. What the beam is gonna do? Take a look at this beam. It's gonna receive first. Okay? Take a look here. What do we have here? Well, we have a beam. And what do we have in the end of those beams? Well, I have other beams. Okay? That we call girders. Um, and what those girders, other beams are doing? Well, if you take a look at 2D, they're supports. They're supports, guys. If I have the load here, how this beam is gonna put the load on this other beam, this girder? Well, it's gonna be the what? The support reactions, the reactions that we have been calculating so far. They're gonna be loads on this second beam, on the girders. Okay? And after that, slab. This first beam, this second beam. How this beam is gonna put the load on the column? What the column is doing? The column is right here, guys. Take a look again. What's gonna be? Once again, reactions. Reaction is gonna be the force on the columns. Then I'm gonna have a column right here applying the force. I believe you guys did in the mechanics of solids, buckling of columns. You apply a force. If Santiago, Dr. Solaris had time, probably he did that. Force on column, you did buckling. See the path here? There, column two, foundation. Here I have a foundation slab, but I could have a deep foundation here. See? Now, that's what we start asking ourselves. If I remove this column here, okay, I don't have anything to go this load here. Now I have to analyze this whole structure. The span is going to be, bigger, okay? I'm going to analyze if this is going to be able to support all of this span and all of the load that's coming from this girder here. Instead of going to the column, now go direct to another girder. Is going to be able to support? I don't know. Everything started here. Let me highlight this one here. Load path. Sounds good? Any questions? Okay. So this is what I want you guys to start visualizing. Okay. This is very important, especially if you are going to do structure concentration. Okay. Especially. But of course, everybody needs to have this understanding if you're in the structure or not. So that's why it's a required class to everybody. Now, we talk a little bit about structure loads. Sorry, the load path. Now, Bruno, how we know the loads that are going to be applied in this structure? Well, remember that I talked self-weight. Self-weight, I'm going to get there. We can calculate self-weight. Okay, we can calculate. We have the cross-section of a concrete beam. Well, you know the specific weight of a concrete, we can get there. But what about the other loads? Okay, we have some building codes, some designing codes, okay, to guide us about the loads in the structures. Okay, for example, one big one is this one here, the minimum design loads for buildings and other structures. This is from the ASCE. Okay, 7. So this is a document. ASCE 7 is the minimum design loads for buildings and other structures. This document is going to talk about all the loads, even the self-weight loads, the dead loads, but it's going to give you the values for live loads, because if you are talking about a house, the amount of people that are in the house is different in a classroom. Do you guys agree? So the loads, the live loads that I'm going to consider, they are different. The live loads for a parking lot is different from a classroom. So another value. All of them are stated right here. It is one here. Okay. And just to let you know, I do have a class, I teach a class at CEE that we go over this document from beginning to end. We analyze all the loads, okay, in deep. Here I'm gonna touch a little bit about them, but we're gonna go deep in this class. And actually, hopefully, I will offer this class in the spring, okay? So if you want to take this class, you're in the structure um, concentration, I will ask you to take that class. If you're not structure concentration, but you want to take as an elective, you can take that class. But we're gonna go over all these loads for building and other structures, okay? But also we have other designing codes. Um, if you are, most of you, after taking this class in summer, next fall, this fall right now, you can already take concrete design. And guys, for concrete design, you're gonna use ACI. Sorry, ACI. ACI is gonna give you all the documents to design the concrete beams. Okay? Next spring, we're gonna have also steel design. Okay, steel design. That you're gonna use AISC. Okay, and for highways, we have ASHTO design. Okay, uh, railway, you have another one. Let me talk about this one here. National Design Specification for Wood Construction, American Wood Council, AWC. Okay, this fall, I'm gonna teach a class named Timber Design. Timber Design, Wood Design. I'm gonna use this code right here to design a house, to design wood frames. Okay, so we have a lot of resource. Okay, uh, I used to say that for structural engineering, we of course we don't need to know everything. Okay, we don't need to know by our mind or like top of our mind every equation, every requirement, but we need to be able to go to the documents to design codes and kind of have some um, knowledge where we're going to find those things. Okay, we are those who apply the codes in order to build. Okay, in order to design. That's structural engineering. Okay, we design the stuff. We go and take a look at the loads. Okay, maybe you're gonna be the one in charge just to be in the side, the construction side, construction management. You're gonna be dealing with construction scheduling, payments, blah blah. Maybe you don't know the laws that are considered for that design, which is okay. It's not your job. You're construction management engineering, okay, in that concentration. Okay, but if you have some understanding, you're gonna see in the drawings, okay, in the plans, drawings, always in the first page, you have like the loads that were assumed for that design. If you have an internship right now, I invite you, I ask you, go right now in your plans and the drawings, find the structured drawings, and you're gonna find the first page probably loads that were considered for those one. You're gonna see that live load, that not dead load, but live load, snow load, wind load. You're gonna see there. Okay, most of them coming from this one here. What are you gonna see if you are working internship for house framing or house construction in wood framing? It's gonna be right there in the structure drawings, designed by the requirements of AWC, using the National Design Specification, blah blah blah. Okay, that's what we use. Now let's talk a little bit about each of those loads. Okay, as I said, here I'm gonna just touch a little bit. In the homework, you have a question regarding loads as well, but I really go deep on it in my structure loads next spring. But this is a good understanding for you, at least for everybody have to have this understanding. So that's why I touch it here as well. That load, guys. Well, that load, as I said, most of the times what we have the specific weight for the materials. Okay, so the dead load are the weight of the many structure members. Okay, that are permanently attached to the structure. Okay, for a building, weight of the columns, beams, girders, floor slab, roofing, walls, windows, pubbling, electrical fixtures, any other attachments, all of that goes to dead loads, dead loads. Okay. So for example, right here, can I zoom here? I can zoom here, you guys can see. Okay. Walls. What is the specific weight for a 4-inch? What happened here with my, okay, 4-inch clay brick. Okay. I have, if the wall is 4-inch, okay, the width of the wall, I have, let's say 1.87 kilonewton per meter per square meter. Okay. How many square meters of wall I have? Multiply, I have the weight in kilonewtons. Okay, or pounds. Let's talk about pounds for 12-inch clay brick. 115 pounds per square foot. How many square foot of wall I have in that specific area? Oh, 25. So 25 times 115 is going to give me a number of pounds. That's going to be the weight of the wall. And that wall framing, remember using framing, I'm using 2x4s. Okay, 2x4s with plaster on side, two sides, unplastered, just the 2x4. I have windows. Okay, I have exterior study walls with brick veneer. Okay, most of the time we have specific weights. The floor fill, okay, concrete per millimeter, or per inch of weight of height of concrete. We have 9 pounds. Lightweight concrete, stone concrete, ceilings. Okay, what I'm gonna put in the ceilings? Right here I have specific weight. Okay. Also, I'm gonna give an example in a moment. Okay. We also have here for some materials. Okay. Aluminum, concrete, once again, clay, sand, masonry, okay, plywood. If you're talking about steel, wood, we have different types or species of wood. Douglas fir, southern pine, and spruce. Okay, different weight. Okay, with wood I'm gonna use. Okay, in my design, with you, which piece of wood I'm gonna specify, because there are different weights, different considerations. Okay, depending where you are in which area of the United States you are, you're gonna find some of them. Most of them you're gonna find Douglas fir, but if you go to the south, you're gonna find southern pine. Okay, so those are the dead loads. Let me give an example. Okay, did I solve this one here? Yeah, I solved it already, so I don't need to to solve it right now. So that loads. Example. Take a look. The floor beam is used to support a 6-foot width of lightweight plain concrete slab. Talking about slab, take a look here. This is the slab. Okay, this is the slab. It's saying this is a concrete. Let me put it here. Let me start writing. Okay, so this is a slab. Slab, let's use orange. Slab, actually concrete slab. Okay, 6 foot. So right here, it doesn't show, but I have 6 foot of slab, orange. Concrete, lightweight concrete. Thickness, 4 inches right here. Thickness of 4 inches. Okay. The slab serves as a portion of the ceiling. Okay. Ceilings for the floor below. And therefore its bottom is coated with plaster. So right here, how can I show it? Right here on the bottom, we have plaster. Okay. Furthermore, a high 8 foot high, so let's put blue here, 8 foot high, 12-inch thick, lightweight, solid concrete block wall is over the top flange of the beam. So right here, this is the wall. Determine the loading of the beam measured per foot of length of the beam. Okay. So how I do that? Take a look. Using those tables that I show, you can, as I said, this is a like very high-paced class, so I'm gonna just go straight to the point here. Okay. First of all, what do we have here? We talk about the concrete slab. Okay. Concrete slab. I go there in the table that I show you for floor fill. I have lightweight concrete is 8 pounds per 8 pounds square foot, 8 pounds square foot per inch. Okay, so I have 8 pounds square foot per inch. Okay, I have 4 inches and I have 6 foot of length here. This is 6 foot. Okay, multiply all of that, I will have 192 pounds per foot. Okay, because we're talking about beams. Okay, take a look here. Talk about beams, guys. We're talking about the distribute load. So that's what I mean by, okay, measure per foot of length. Okay, is a distribute load right here. So that's why I'm getting 192 pounds per feet. Per foot of this beam, I have 192 pounds. Now, plaster as well, seating. I go there, found here, 5 pounds square foot. I have 6 foot, 30 pounds per foot. Wall, right here, masonry is 105, okay? 105 times 8 times 1 foot, because 12 inches is 1 foot, okay? I have 840 pounds per foot. Sum all of them, what I'm gonna get? 1,062 pounds per foot. Remember from statics, 1,000 pounds, it's 1 kip. So just putting here, I have 1.06 kip per foot. So what I have here is this configuration. Okay. What I do next, very simple. Simply support beam, find the reactions. Then I'm gonna go for the columns and keep going. Any questions? I know it's a little bit faster But just going to the table, we're talking about beans. So I need the load by foot, okay, distribute load. And then I start doing my multiplication right here. Sounds good? Okay. So I have one problem like this one here, in that you're gonna use the same tables in the homework. So probably after class you can already come here and check it out, try to solve it. Let me know if you have any questions tomorrow. Okay. Live loads. Okay. Live loads, as I said, can vary both in magnitude and location. Okay. They may be caused by weight of objects that we put there just for some short period. Okay. Or by moving vehicles. The floors of buildings are assumed to be subject to uniform live loads. So even though we have the floor of the buildings, and we have like maybe some part of that classroom is going to be the professor, is going to be the students, and the other part, but we consider the whole floor as a uniform live load, meaning in for every corner, for every point of that floor, we're going to put the same load. This maybe is not the reality, but we are just playing safe. Okay. So for example, for classrooms, as you can see here in the bottom, the live load is 40 pounds per square foot. So when we design the slab, each square foot of that slab we're gonna add 40 pounds. Okay, 40 pounds. And we have some, depending where we are, we have different values. Okay. Many codes allow a reduction in the live loads for the floor, since it's unlikely that the prescribed live load will occur simultaneously. So even though we design for the whole floor, some codes we can reduce it. Okay, so for example, instead of 40, we can use 25, 30, depending of the floor that we are, okay, depending of some calculation. Right here in this class, I'm not going to touch the reduction of the live load. This is going to be the other class, okay? But just to let you know that we can reduce that load. Sometimes the load looks like so much, but we can reduce those loads depending of the situation, okay? So those are the live loads that we have. Okay, all good? And then if you take a look, 40, like take a square here, 1 foot by 1 foot, so we have 1 foot square, okay, and try to simulate like 40 pounds per foot square. Is a lot of people here, so many people, so we already playing very safe. Okay, let me see, 4 o'clock right now. Okay, I'm not gonna be able to finish it, but let me just see here. I stop it here in the next few slides. Okay, wind loads, another type of loads. um, Again, we have the wind, we create pressure, okay, that can cause massive damage to the structure, okay. So whatever we have like pressure here, sometimes same time we have pressure here, we have suction here, meaning this side here. So one is going to be pressure on this side of the wall, another one pressure inside the wall, the exterior one, the interior one. So as you can know, like we can have some kind of movements in this house, which is gonna create sorry, I'm gonna create displacement, vibrations. I'm gonna create force, internal force, moments. Okay, so these are the wind loads that also create uh, loads on our system, and we have this. We have to design for loads. We have to design for those loads as well. Okay, it's not only the gravity loads we have to design. We have to design to wind loads as well. Okay, we have also the earthquake loads. Okay, earthquakes, as you know, just moving. Okay, it's kind of this lumped mass. It's like going to the left, to the right, to the left, to the right, moving the structures. Okay, depending of the magnitude of the earthquake. Oh my goodness. Depending of the magnitude of the earthquake. So we have to design for those seismic loads as well. Okay, uh, and the wind loads and the earthquake loads. Okay, they are specific loads that we design lateral systems. Okay, lateral system. I'm gonna tell you about it in a moment, because those lateral systems that are going to be able to get that kind of load and distribute to the other loads, to the other elements. Sorry. So, for example, the columns, they are mostly gravitational. Okay, they receive the gravity loads, the live loads, and the dead loads. But we need some elements, okay, in order to get the lateral loads and move these lateral loads to the columns. Okay, so these lateral loads, they're gonna be um, held by the lateral systems, and the lateral systems are going to uh, follow. We're gonna help the load follow the path to the columns, to the beams, to the floors. Okay, so we need lateral systems. I'm gonna tell you in a moment. Just to finish in talking about loads, um, and for you to know about it, we have some load combinations. So once we calculate the dead load, live load, rain load, snow load, all of that, we need to combine them. And in order to combine them, okay, we have two methods: the ASD, okay, and the LRFD, okay. Um, Today, mostly of the designs, they are going to be in the LRFD, meaning that we have the safe factors already on the design. Okay, you're gonna learn when you're design, you have a lot of safety factor, and I think for the mechanic of solids, probably Dr. Solaris touched it a little bit of safety factors. Okay, meaning that we reduce the strength of the materials, the strength of the beams, the strength of the columns. Okay, and we assume they are a little bit weak than they are. Okay, however, in the LRFD, we kind of do other thing as well. We decrease the strength of the materials, but we also increase the loads. Okay, so we kind of are safe in two places. We increase the loads by a factor, meaning this is the load that I calculate, but now I'm going to put more load. So I'm going to design this element for so much load. Not going to be able to fail. Plus, we also have, we decrease the strength of the material. The material would work for 1,000 kips, But because of my safety factor, I'm assuming he's holding only 800 pounds. So you see, you have two ways to play safe in LRFD. In the ASD, they are getting not so much use anymore. You play safe just for the material, okay? Just for the material. And when you combine, you just one single factor of safety. Okay, here you just add pretty much all of them, just dead plus life, dead and life for the roof, and keep going. Okay, you don't have a lot of combinations. It's not only three. Here just showing three combinations. But take a look. You have combination one that's just dead load. Combination two is dead load, live load, plus or live load for the roof, or snow load, or rain load. Meaning that these two here, I have 2A, which is this guy here. Okay. I have 2B, which is those two plus this one. And I have 2C, which is these two plus this one here. For 3, I have 3A. One, one, one. 3B, one, one, this. C, one, one, done. D, this one, that one. E, F. So in 3, I have A, B, C, D, F combination. Then we have more. Okay. We need to check for each one of them. Okay. The one that is the highest is gonna, of course, is gonna be the one that we're gonna pick because it's gonna give us the most load in the structure. So we combine loads. Okay. For just touching here for concrete, so concrete and steel, LRFD. That's what we have been using. All the codes are updated for it. If you go to the construction site, that's it. Okay. However, for wood, which is timber, most of the code are still using ASD. Most of the companies are still using ASD. And if you take my class next fall, timber design, we're gonna use ASD because that's what they have been using. Okay, load combination. Let me just talk about lateral systems, and that's it for today. Okay, as I said, lateral load resistance system, or LLRS, they resist lateral loads, wind, earthquake. Okay, so as you can see here, we have the wind and strike to what wrecking the building, moving the building. Okay, and we have this effect. To resisting it, engineers will use bracing systems. Okay, bracing systems. Most of the time, they're gonna be the bracings that we know bracing. Okay, as you can see here. Okay, those bracings, they are there. Sometimes you go and you see, wow, what is this? This kind of being like this X, okay, between this wall, or sometimes the architecture get mad because have to use bracing and he cannot put the window here anymore. Why we have those things over there? Well, because those are the ones that are going to resist the wind and earthquakes. Okay. Let's say we have the wind here. Once we have the wind, and this is gonna go all the way to here. Okay. This guy is gonna be in tension. Okay. And it's gonna resist to keep those together. Okay, to keep those structures together. Bruno, but it's not all of those buildings that we have this cross section, like cross bracing here? Of course, because we have other type of lateral resistance systems. Okay, we have these braced frames right here. Okay, could be just one, could be in X. Okay, could be like this, depending of your design. We have what we call shear walls. Okay, this is common. I bet you pass through a construction site. Maybe you get an internship. You're doing concrete over there. You have the concrete slab. You have the concrete columns, and then you're gonna get in one part of the building. Everything is open, but one part. Sometimes the corner of the building. Take a look, and sometimes where the elevator goes. Take a look where the elevator goes. You're gonna see this closed wall with concrete walls. Those are shear walls. Shear walls. And they are there not only because it's an elevator, it's not only because it's a corner. They are there to resist the wind and the earthquake loads, the lateral loads. Okay? So there are reasons they are there, and there are reasons why they are in the corner. They are in some important points of the building. Okay, and most of the times the engineers already use the shear walls to have the elevator over there. Okay, you save some money. You're putting like fake walls or where the elevator goes, and they're gonna help the elevator, but they're gonna act as shear walls. Okay, plus plus we have moment frames. What is moment frames? This is also mostly of the concrete design. Okay, where we concrete the beam together with the columns. Okay, so the connection is a connection where if one move, the other one's gonna move. Okay, they are moment connections. Okay, the moment that we have here, we're gonna have here as well. Here is gonna just transmit to the others. Okay, so we have different types of lateral resistance systems uh, in the buildings. Here a different resistance system as well. Once again, cross braced, inverted V brace, single diagonal bracing. Okay, eccentric bracing. Okay, where we can have like windows here. Um, this is common as well for steel frame, where we have the connection, but this connection is not a moment frame. So we're gonna have this knee bracing here. It's gonna help us with the lateral loads. Okay. Um, Next time you pass below a bridge, you're in the highway, the 95, or you're at Seaway, leaving the metro station. Look up. You're gonna see those bracings. Why they are there? Wind. They are there to resist the wind. Of course, they have another rule, another um, objective why they are there. But they are also there because of the wind loads, okay? Because the lateral resistance system. When you're gonna go for steel design, you're gonna understand why they are there as well, okay? But one of the reasons is wind load, wind load, earthquake loads for when we have um, shear walls, corners, diaphragms, diaphragms when we have like these panels um, for wood design, the panels, the plywoods on the floor, most of the times they help us with the wind. They distribute the loads um, through the other elements. Okay. Uh, so I will stop right here. Okay, the lateral resistance systems today. Tomorrow we're gonna keep going for this presentation. um, where I'm going to show you a little bit of the example of the loads, and we're going to start the truss. Okay. Then we're going to keep going until the time is done. And then on Thursday, before the SEP 2000, I'm going to finish the, the truss problems and then go right to the SEP 2000. So it's going to all work out for us. Okay, so I'm stopping here. Um, then, yeah, I'm going to stop here. Then let me stop the recording. For those who are watching it, please watch the next one to the continuation for this lecture. Let me stop recording. Then if you have any questions, you can ask me. Where is the record?